Hello everyone, welcome to what will be pre-lecture number 4. We're going to talk about how we go about doing more calculations with chemical equilibria. So jumping right in, basically depending on the information that we're given for a chemical system, we can get a whole slew of other chemical information out. And that usually has to do with either our K value, our equilibrium constant, is what that is also known as, or the initial or equilibrium concentrations. And so let's put this to an actual chemical system. Say we think about this reaction where we have carbon monoxide and hydrogen gas making methanol. This CH3OH is methanol. And we're told that this reaction is occurring in a 5.19 liter flask at a given temperature. We have 0.185 molar CO and 0.224 molar H2. In case it's not clear from this question, these are initial concentrations. So basically before anything happens, those are our initial concentrations. And then at equilibrium, our flask contains 0.0520 molar methanol. We're asked to calculate Kc for this reaction at this temperature. And so basically information we're given here, we're given initial concentrations of our reactants, of our two reactants. Because we're not told anything about the initial concentration of our product, we can assume that that initial concentration is 0. We're also then told the equilibrium concentration of our product. And so what we need to do in order to solve this problem, or some missing information that we can get from what we are given, is we need to find the change in concentration of our reactants in order to determine ultimately our equilibrium quantity of what we have. And then, of course, this question asks us to find K, and so can we actually find that? So I want you to think about that. We'll come back to that in a moment. We have another question here. So maybe we're given slightly different information as a part of our question. Say we have this as our equilibrium expression. And this time we're given K. So we're not asked to find K in this situation, but we are given Kc in our chemical equation. And then we're told that our reaction mixture initially contains 0.1 molar NO2 and then 0.01 molar N2O4, and we're asked to find then the equilibrium concentrations of our reactant and our product. So we're given different information here, but again, this tracks on we're given initial concentrations, we're asked to find equilibrium concentrations. In order to do that, we need to find the change in concentrations, right? And so basically that was just what I said. Sorry for getting a little ahead of myself. And so there is a tool, or basically a method we can use for solving these sorts of equilibrium problems, and we call them ICE charts. And so ICE itself is an acronym that stands for Initial Change in Equilibrium, and an ICE chart is something that we generally construct around our chemical equation for the system in question. And so let's say we go back to question 3 here. This was the first question we saw in the pre-lecture video. And so we're given all this information and we have our chemical equation. We can construct this ICE chart. So again, initial change in equilibrium, where we plug in our initial values here. These are numbers that are given to us as a part of the question. Again, because we're not told anything about the initial concentration of our product, we can assume that we start with a concentration of 0 there. Then we can figure out our change in concentration for each of our species by just kind of thinking logically about this. If we are going to form some amount of product, basically if we start with just reactants, we know we're going to form some amount of product. In this case, we know actually how much product we're going to form. Then we have to lose some variable amount, which I call X here, of carbon monoxide. And because we have 2 equivalents of hydrogen, our stoichiometric coefficient of 2 there, for every equivalent of carbon monoxide that we lose to produce methanol, we lose 2 equivalents of H2. So basically we're going to lose double the amount of H2. And so this 2, again, just comes from that stoichiometric coefficient. And because we have a 1 as our stoichiometric coefficient in front of methanol, we would just say that's plus X. And then for our equilibrium concentrations, basically whatever you fill in to this row here just ends up being a combination of your first two cells. So for carbon monoxide, we have 0.185 minus x. We combine that. We have 0.244 minus 2x for hydrogen. And then we're given this 0.0520 molar as a part of our information in the question. And so from all that, we can make our ice chart, and then we could solve for K from here. And we'll actually do that to start class. Okay? If we think about our second question, question number 5 on our in-class worksheet, things are a little bit trickier. So in this case, we're given just initial concentrations of both reactants and products, and we don't necessarily know which way the reaction is going to go here. And so I put minus x and plus x here, but we need a way to figure out which way is this reaction going to go. And so I want you to think about that. That's a question I'll be asking to start class. And then how do we figure out the equilibrium concentrations of each of these chemicals? In this sort of situation, we're not actually told what our equilibrium concentration of either chemical is. So how do we figure that out based on the information that we're given? And then from that point, how do we find, or not how do we find K, because we're already given K, but how do we find that equilibrium concentration? Okay? All right, that's it for our pre-lecture. Hopefully gave you some stuff to think about as we head into class on Wednesday. And if you have any questions, please do let me know. Otherwise, I hope you have a great day.